Thank you. Hi, Inga. Hello.
Hi.
And you can hear us?
I think they can.
Yeah. So I think that now we are around 5 minutes past time, so maybe we will just start this session. And maybe some more will drop into this session, or maybe not. But at least we are somebody here going to work on our project we've been working on for some years now, called Shitty Robot Gala. And to start out, there is something that we've been working on here at Fablab Spinderihallerne for 3 years now, where we actually gather a lot of teenagers to come to our old factory and build stupid inventions like shitty robots and funny creations and stuff like that, to build up a lot of humor, a lot of fun stuff with technology.
And last time we were like almost 400 teenagers gathered here, all building shitty machines and robots.
Yeah.
It was quite fun.
Yeah. So robots that do stupid stuff, small machines that do everyday tasks for a lazy teenager and stuff like that, to kind of get them more involved in technology. So technology should be for everybody, and sometimes the kids in the schools and high schools will feel that the level is very high on working on technology. So this is kind of our way of getting them involved in working with technology, and not being afraid of just doing it. Build something. Yeah. We have a couple of slides that we will present to you, and after the slides we will kind of start the workshop on building something together with you, hopefully.
And when we reach that point, it would be nice if you can turn on your camera so we can see what you're building, and we kind of build together and just drop in with you guys. So please feel free to do that.
And it doesn't matter if it's old coffee filters, or if it's clay, or if it's microcontrollers and stuff like that. Legos, everything you can find lying around is usable for this workshop. So so just look in the drawers and see what you have. Yeah, and I will start the slides right now, hopefully. Can you see the slides? Yanni, are they on? Oh, thank you.
Thumbs up.
So we have our big guru here, Neil Gershenfeld, and yeah, as you know, we are Fablab, as you guys are, and we kind of started on this what do you say, sentence like, give ordinary people the right tools and they will design and build the most extraordinary things. So here at our old factory, we are open for citizens, for startups, small companies, for schools. We have the high school teachers, the public school teachers, and we have some from the university coming to our lab and experimenting and using each other to getting more knowledge and getting more things done. So this is, I think, when we look at this sentence, we kind of pinpoint this with ordinary people. We are all ordinary people. Some are high educated, some are lower educated, some are girls, some are boys, some have a degree in design, some just like to tinker, and we meet here to invent stuff, to do stuff, to build stuff, to be makers and explore. And that's really important for us to say. It doesn't matter the level of your expertise. It's about the heart and the fire of wanting to build stuff. Yeah. So a great thing about the Fab Lab and what we try to tap into is this: experiment, fail, learn, repeat. So we see fail as first attempt in learning. So try, do it, and make an attempt. And maybe you fail, And when you fail, you have to look at your fail and improve it, make it better, make it work. Like when Neil Gershenfeld talks about making a big dream come true, break it up into small circles, and then in the end you will have made your final project or your first prototype. So we look into these, make fails, and you will learn. So there's Shitty Robot Gala. It's not a competition. No, no, no. It's not who get the fastest car to drive to Mars or what doing, you know, all these, we have all these, what you see, competition here in Denmark, where it's you have to be the fastest, you have to be the best coder, you have to be best to program this and these and that, you have to do the slickest invention. It's not about that. This is a gala, so we will make a big party, and we will make glitter and smoke and have kids and teens in all kind of ages, from high schools, from public school, making crazy stuff. A lot of fun, a whole lot of fun, and just doing stupid inventions. And that's what it's all about. So this is some pictures from the gala. Last year, as Simon said, we were 300 kids gathered here. Smoke, glitter, a big party, popcorn, everything, and doing robotics, doing machinery, doing coding and program, but it has to be fun. Yes. In Denmark, maybe you will say something.
Yeah, we have this old cartoonist, and he actually my kids, my boy, he's named after his name is Storm. He's born in 1882, and he was both a writer, a cartoonist, an animator, illustrator, painter, and his cartoons just fills a big part in our life, in the Danish newspapers, and so every time you see something that is built in kind of a funny way, or it's a bit awkward, or it's the kind of almost work, you call it a Storm P invention. And he did these drawings, and sometimes when we do this with the kids in school, we start out with his pictures and try to find out what's going on in them. So we try to look and analyze the mechanisms, the pendulums, the mills, ramps, pumps, catapults, pulleys, tilts. He was like drawing before electricity, so it's all like analog and strings, pulling strings, and moving gravity and stuff like that. So, for instance, here he's trying to turn off the light after we're going to bed. So he pulls like a string, and then the water pulls down
to the spoon.
To the spoon that hits the apple, that shifts the weight of the boot, that will blow water out on the lights. So a lot of what we think, we kind of start with these pictures, and then we think what would it have looked like if he had like a microcontroller or motors or stuff like that.
Yeah. So you can see this is before electricity came into the houses. So it was like a candlelight he should blow out. So if he could build a robot, what would Storm P have built?
Yeah, and on this picture, he doesn't have like an electronic doorbell. So when somebody comes into the door, the boot hits the apple, falls down the umbrella that pokes the puppy, that goes for the sausages. So he pulls the string that activates the hammer on the bell, and it gets amplified down the tube, so he can hear that somebody's entered the door. So could we build something with these kind of mechanisms, but put some power and microcontrollers onto them? That would be awesome.
Yeah. And then we stumbled upon this girl. She's great. She's called Simone Geertz, and she built shitty robots. And the first time we were making shitty robots, we were in a tight dialogue with Simone, and she was kind of our role model into just do it. And she talks about that that you need a lot of joy and humility. Sometimes get lost in engineering. So it has to be this great, totally finished built machine, but there's no fun. So she's really into, let's have fun building it. And when you have fun, when you have creativity, it increases curiosity and it drives the desire, it drives motivation. So of course, when you build shitty robots, you have and when you work with technology, you have a high risk of doing a failure. You have a high risk of not making it work. But if you do a shitty robot, then it's part of the game.
When
okay.
You're almost guaranteed success.
Yeah. And we love her for that. So of course we are talking about her agenda with building shitty robots with the kids. Don't be afraid to fail. Don't be afraid to make like 3 mistakes before you end up doing something brilliant. And remember, it has to be fun. When we talk about shitty robots, of course we know that building a robot is really also a high learning curve. So we have this definition of a shitty robot that we need to build some kind of automated machine that could execute some kind of task for these teens. So it has to be something that we program, a microcontroller, any given microcontroller that we program with some intentional coding, and that it has to do something with a mechanism. Let it slap something, let it blow up something, let it sprinkle water on something, you know. So it has to be coded and programmed, but also do something with an automated mechanism. Yeah. We have this video from Simone that we want to show you about her shitty robots. We go a bit into the video where she actually building something. So we want you to see this.
Arduino Uno, and I'm having the Arduino Uno control this relay that starts this motor. This is a motor from Servo City, and they have like these really nice parts. And I tried to get Servo City to sponsor me, but they were like, no. But I still want to put it in there. These parts are freaking awesome because they have like these Actobotics. They're just aluminum and they're really easy to just like put stuff together, and it's super sturdy, way sturdier than I normally build stuff. And this motor is like, it's pretty strong. It's 165 rounds per minute, and it has, I think its stall current is like 20 amps. So before I started using this relay right here, I burnt up a fair amount of transistors. There's nothing that makes you feel as competent as the smell of burning electronics. You're like, good job, Simone. You got the situation under control and you're burning shit up. I was kind of hoping to just find like a normal transistor that could provide enough current for this one and that would still be able to be controlled from a microcontroller like the Arduino Uno, but I think that was a fool's errand because there is no such transistor. Or maybe there is, but then please share it in the comments because I haven't been able to find it. This is just a box for band-aids. I mean, it's a pretty terrible construction. These are just like normal, like, what do you say in English? Älgar in Swedish. I really don't want to talk my projects down because they're kind of like the children I never had. They're their uterus. Simone, you're 25, get a grip. Let's transition into the wake-up machine working right now.
The wake-up machine.
Okay, so I hope you still can hear us. We just stopped the video. This was a little piece from her video on YouTube on her official channel. And as you see, she's not afraid of burning off transistors or just finding whatever scrap piece of junk she has in her, what do you say, in her Fab Lab, and just make something. This is Caroline on the picture right now. You can see Caroline is a 5th grade student. I think she's around 11 or 12 years old on this picture. And she actually built this catapult, as you see. This is an entertainment center for her dog. And Caroline says, hey, I'm a lazy teacher, a lazy teenager. I just want to lay on my bed or lay on the couch watching the series on TV and let this entertainment piece do it for my dog. So she built these catapults with 3 servo motors, 1 servo on each catapult, and she can lie a biscuit for the dog on every catapult. And then she programmed or coded her, made a code for her Arduino, which just had a sensor on, and doing the input part, and the output is doing it with the servo motors. So when the dog was running through the catapult, it threw 1 cracker for the dog, and the dog were running for the cracker, and it was running back to the catapult again. It sensed the dog, and then it made 1 more servo through a cracker more, and you could do that 3 times. And she had it exhibited at our shitty Robot Gala, and it was so fun. She actually got the mayor to run for a cracker, I think. Yeah. And then we switch slide. This is a video from the gala. Soon we will be building, but I just want to show you a little video from our gala. I hope it's going through the space good, but it comes here. This is from the gala before Corona. Okay, so how to make almost anything? What about how to make almost anything in a shitty way? And what do you want to make?
We're gonna shift our scene. And when we shift the camera view, you'll find Johan, who's he's a teacher, a primary school teacher, and he's been doing maker education here in our lab for the past year, and he will be building with us today. So we're just gonna move over to him. So I'll see you on the other side. So we hope you can see and hear us. We will now start the actually hands-on workshop where you guys should be building, and it would be awesome if you turned on your camera. You can put it down on your table so we just see your hands and building stuff. If you have some materials, You see, we have kind of a lot of materials, and if you have just something to tinker with, it would be perfect.
And is there somebody who could just say a little something? Are you there? Are you online? Can you say a peep?
Beep.
Thank you.
Perfect, Inger.
Thank you so much. So I don't know what you have out there. I tried to describe in the workshop sheets that maybe you tried programming some kind of microcontroller. Maybe you have hot glue. Maybe you have feathers. Maybe you have Legos. I don't know. But we have gathered something around here from our lab. You can see some candy, some hot glue, some ultra bit, microbit controllers. We have some Arduinos, makey, duct tape. Of course, we have duct tape, and soldering stations, clay, everything. If whatever you have, let's try to build something. And we were thinking this could be some kind of megaton. So we just free our creativity, trying to build something. If you don't have anything at home to build with, please make a drawing or something then. Let's make a sketch of your craziest invention. Something that could help you with doing something that you don't want to do yourself at home.
Some crazy everyday problem, just you know, another gimmick for your next party. Any crazy stuff you can come up with.
Yeah. And we also have some of the kids' creation here at the table. Maybe you can see here, this is one of actually Caroline's catapults from the dog feeding machine. Maybe you remember this. I don't know about the other countries, but this is actually a kid who make a drinking game. I don't know, maybe he talked with the teachers, I don't know, but it's actually really cool. It's a spin the bottle, what do you say, for the spin the ball game, yeah. And it's with an ultra bit, yeah.
And somebody here did like a toothbrushing machine, so you wear the helmet and it brushes your teeth, maybe, or it just works like a windshield cleaner for your glasses, I don't know. So stuff like that.
Yeah.
But if you don't have any electronics where you are, like Peter said, then do a drawing, share your crazy ideas with us. Please turn on cameras if you like to. It would be really nice, and we don't feel alone.
Yeah.
And then we just start building. And if we see something interesting at your place, we'll might ask you some questions, or like for you to tell about what you're doing or what your idea is.
And please also just ask questions for us. If you have questions for the program, if you have questions for what we are doing, please ask. We will keep you in loop what we are doing right now. So yeah, are you ready for this?
So that's the plan for the next
Yes.
5 minutes or 30 minutes or something like that.
Yeah.
And then we'll see what you all invented. Perfect. Let's start building.
Yeah.
So the plan is, I think we're gonna have to make a hole here for this and get this for like the whole motor until the lid.
Here, yeah, the lid should be on top.
So this is so you have a ruler.
Yeah.
So 2.5 centimeter.
If you can see that.
Yeah. Exactly. Jetzt noch ein das Video. 10. 10. Should also have some awesome light in here afterwards. And feathers.
Caterpillar here.
Perfect.
So right now I'm just working a bit with a microbit. Here in Denmark, we have a similar program called Ultrabit, where they use the microbit and give it to all the schools. So actually in every school in Denmark, there is this little microcontroller computer board with a lot of stuff on. And you can buy a whole lot of extensions thingy to put on this one. And you can, the schools will use a lot of money on buying stuff for this one. They get this one for free. That's really great. But then they buy all these extensions thing. And I was just thinking, this is a soil moisture meter. So it's actually some foil, copper foil with a little transistor and some resistors on here. And then you can program this piece with some block programming and set some different values into this one, and it can measure the resistance in the soil. And I built this this kind of cactus. It's not doing that great anymore, so I think I will keep an eye on this one and try to build this one myself, this moisture meter thingy. So I was just wondering if I could use an old you know, to put on up close. Break that down and put some copper foil on this one and solder something together, and hopefully I will get to some kind of moist meter that could measure the moist of my cupcake. So I need the perfect cupcake, and I need the perfect amount of moist in my cupcake. And I just need to do a lot of tests and eat a whole lot of cakes to see what is the perfect setting for doing this kind of cupcake. I made a kind of sketch as well here. You can see a shitty cupcake moist meter.
Brian, you was soldering something. Yeah. What are we building today?
We're building a machine that can help us select, because when we tinker, we always have snacks. Mm-hmm. And sometimes when the snacks is like M&Ms or Skittles, we get stuck because we can't choose which color we want to eat.
Oh,
so
no.
This machine is going to help us decide so that we can concentrate on eating the sweets.
I think, Johan, that's what the professors call a wicked problem.
Yeah.
Exactly.
Let's save the world.
Yes. Yeah. So we're also using a microbit and a DC motor, and then we're going to paint this piece of cardboard in the colors that we have in these cups of the sweets. Yeah.
Perfect.
Cool. So it will select the color of the MM for you.
Yeah. And,
so there's no more, I don't like the blue ones, I only love the red ones.
But you can customize it, because you could either divide it evenly in 5 spaces, or you could like make the red one larger if you prefer that.
Or you can cheat with your code and just make it stop in the same color every time. So you skip the randomizing.
Yeah.
Yeah.
Exactly.
How deep should the box be to hide? How much? Think about it.
Is somebody building anything out there?
Maybe just bend them and then glue them and bend them and glue them.
Okay.
Hey, Rasmus. Yeah. We're building something. Can't hear you. There's someone picking my nose right now.
You need another strip?
Yeah. Duct tape. Fix some.
Yeah.
Does anyone have a great idea for something they want to build or draw? It's okay if it's just an idea.
Could just be something great idea from the top of your head, something that you always wanted to build.
Perhaps they're busy building.
Yeah.
Let's hope so.
So I can't bake in here. I don't have any dough. I just bought this muffin. So I was actually thinking of, I need just to test it. I need to provide some moist in my cupcake. So I actually just cleaned up this dispenser, and I will try to moisturize my cupcake just to test if my settings are right. Let's see here. So what's the perfect amount of resistance in a cupcake? I don't know. I actually like a cake a bit of dry, but most like them moist. So let's see. This is just water.
Hot glue sticks.
Hot glue sticks. There. There.
Hot glue and gaffer, that's all you need. Duct tape
And feathers.
and feathers, of course.
Yeah, of course, feathers. I don't know if you can see this, but I programmed my my microbit, so it has like three different values. One where it does a big heart, and one where it does a smaller heart, and one where it does like a cross, like X's, like I'm dead. I don't have any more moist in me. Right now, it's actually number 2 heart, so it's semi-moist. Of course, the cake doesn't have to be wet. It has to be maybe semi-moist. So maybe this is a perfect cupcake. And I just put some copper thread on these Lego bars, I think they're called, and down in my cupcake. And I think that my second iteration would be to put on some resistors and a transistor to maybe make it function even better.
Then dividing the plate into 5 colors of candy,
Exactly.
and that's like 72 degrees.
Yep. If it's gonna be fair.
Oh, you did like a
Small template.
Mhm.
Maybe we should run it before we put the motor on. This one's not the red one.
Yeah. Our favorite one.
Yeah. So
Coloring or gluing on snacks?
gluing on snacks.
Gluing on snacks.
Oh yeah, you could also glue that. So you're gluing a M&M on
Yeah.
every. Oh yeah. Are these fake M&Ms?
Nope.
No,
Okay.
so it's totally
Oh,
waste of
it's like
good
the
candy.
expensive M&Ms. Yeah.
They still work,
Okay.
of course.
Wow. Nu forsvandt billedet.
Ja, kom nu.
Okay.
Jeg skal bare post lænket til sidst.
Hmm. This is really beautiful in here. Gluing candy on a cardboard box.
We should do something with some kind of light on it, I think.
Yeah, there should be some light on it.
And perhaps a feather.
Perhaps, of course, a feather. So should we hide this inside as well? And then we have colors like
On the front.
on the front.
Yeah.
Hello, can you hear me?
Yes, hello.
Hello, Sario.
Hello, hello, Saverio from Shanghai.
Hello.
Hello, nice.
I have an idea, but I'm not sure I will have time to build it now. But it's something I always wanted to do.
Oh,
So I'm
great.
gonna show you
Yeah,
a little
perfect. Please
sketch
do.
that I made. I think this could be a
Ask
very
you,
shitty
Saverio?
robot. So
We're
Ah.
just pinning you.
Just pinning your
Sorry.
screen so everybody
So
can
you-
see what you are doing.
Oh, nice.
yeah,
Hey.
okay, great.
Yeah.
So the idea is the thing is that when I'm taking a shower, right?
Yeah.
Sometimes I move the shower, what's it called, the hose. I move it around when I want to put soap on me.
Oh yeah.
So
Yeah.
I know I should turn the water off, but then
Yeah.
then it gets cold, so just for a few seconds.
We know the
So
problem.
when you move the hose on one side, the thing that happens, some fluidodynamics magic happen, and the shower curtain gets sucked
Oh
in,
yeah, yeah, yeah.
and
yeah.
and it touch your leg, and it's like,
Oh, it's-
Oh
yeah.
no. Yeah.
Sometimes it's cold. Sometimes
Yeah.
the-
It's
the
sometimes
curtain is-
yeah
And sticky.
sticky.
I was thinking of making a robot that has like a fan, like a very powerful one with a distance sensor, and
Brilliant.
when the curtain gets sucked in, this thing turn on and woo, suck
Oh
the
yeah. Yeah.
the curtain back out.
That's
What do you
that's brilliant.
That's a perfect
Brilliant idea.
I was
You have to
thinking
look
about
out for
this.
you have to look out for the big corporates who's on this page right now. They will steal your idea, I think.
Yes, it's-
It's your
I have
idea.
to I have to build it as soon as possible.
You'll be a millionaire.
Let's see.
Wow.
Let's see. I will try to find something around the lab now and try to build something very quickly.
Yeah, just do
Yeah,
some big
yeah,
mock
yeah.
up very quickly.
Okay.
That would be
It's
perfect.
really, really, really good idea.
Thanks for
Okay,
sharing.
I'll
That
Thanks
was
go.
for
perfect.
sharing.
Thank you.
And if anybody else want to share their brilliant idea, I know that the bar is high right now. The bar is
Yeah.
high right now, but please share your idea if you have one.
I have one.
Hi, Inger. Yeah.
Hi.
Uh,
Can you see it?
We will just pin you so you get on the big. Yeah, now we can.
Oh, nice.
Oh, yeah.
Can you take us through it?
So what I would like to do is make an encouraging machine. So
Wow.
every time I need an encouragement, I press a button and then you get the microbit running text, do ce point Inger,
Oh,
and
yeah.
a feather goes up.
Oh, wow. Yeah. Brilliant.
Oh,
I
that's
cannot
really
make
nice.
it now, but
No,
I definitely are going to build it.
Yeah, that sounds
that's
perfect.
brilliant, Inger. Sometimes this is a hands-on workshop, but it's online, and that's sometimes difficult. But the idea is there, and I love that you have the feather, because sometimes we need a extra feather in the hat to keep us
Encouraged and
in the morning. Yeah. Brilliant. And maybe something with a servo motor that could raise your feather, and you have the microbit or the Arduino or something like that that you want to program. I think it's a brilliant task. Yeah.
And if you don't have any electronics and not time enough today, you can just build something quick in cardboard that just shows where the motor goes and how the button looks or something, and you could do something.
Maybe something with rubber bands. That's always great. We actually have this one, Inger. It was a bit of similar, something that could be put in the air. And it was a kid, a teenager, who said, "Oh, I'm so lazy. I don't want to sit all day raising my hand, and the teacher picks me at the last moment," or something like that. So he actually built this one, and it's also like a big catapult. And there was some rubber bands here, and there was this little servo motor, also with the microcontroller or the microbit here, and it just had a bottom. It actually had a big bottom, a big red bottom. So when he pushed that bottom, it just pulled out the trigger, and the hand would go up. And then when the teacher had picked him and he had said what he had to say, then he could load it one more time.
No, what?
Yeah. Oh, a blue M&M. So your Hans machine is working right now. I also want to try.
Oh, green.
A green one.
Yeah, we have to take green.
Maybe we can show it. So now we have, of course, a feather, very important. Turning this DC motor around, and we have a microbit. And what is this? And a servo shield, or
It's a relay.
as a relay. I don't know if you can see. Johan has a relay here.
Like a small breakout board for the microbit, and then a relay.
Yeah.
Yeah. So when you push a button, the relay opens for the power to the DC motor for 1 second. And when it stops, it keeps turning until it eventually stops at one of the.
So where is the bottom?
Yeah.
There. I'll try. Oh, green one. Wow.
And then of course we have some running light here just to show that the machine is activated.
Yeah.
Oh yeah, light. Light is always great.
Yeah.
This is also very important to have in a fab lab. I don't know if you know this, but if you were smoking like a pipe, then you could clean the pipe with this one. But it's like the best little thingy. You can put it onto Legos, or yeah, doing all kind of crazy stuff with these. They are great. Du ved, hvad det hedder? Piberenser?
Pipe cleaners.
Pipe cleaners?
I think so.
Yeah, maybe.
So on the next iteration, we could make like a distance sensor, and
Oh, yeah.
it could be activated by hand.
We have like 10-15 minutes.
A distance sensor. So you don't need to press the button. You can just like activating something with the hand. Can you use your foot as well?
Maybe.
So if you lay down, you can activate it with your foot.
Yeah, just tip the foot.
And then we just need something to put the right M&M in the mouth of you. Nice.
I'll make some holes for the little guy. Yeah. Okay.
Er piberenser lidt leden?
Ja, du har jo stoltråd inde i.
Jamen er det... Hold lige afbakke. Inga, are you still there?
Yes, I am.
What are you working with? Are you working in a fab lab, or are you a teacher, or?
I used to work be at Fablab Reykjavik before
Oh,
I
yeah. Oh,
and I did Fab Academy over there, and
wow.
then I moved back to the Netherlands and I did a Biohack Academy at Waag.
Wow.
And now I plan to do the Fab Textile Academy because I want all three, of course.
Oh,
Yeah.
Connect
cool.
them.
Of course. Oh, yeah.
Where are you doing the Fab Textile?
Can you repeat that?
Where are you doing the last part? Are you doing that in the Netherlands or?
I hope to get a grant next year to do it in at Waag in the Netherlands.
Yeah.
But I'm in the, I have to move out of my house now first.
Okay.
And
So
don't
where
have
in
any time.
where are you living in? We call it
in the
Holland.
Netherlands,
In the
Leiden.
Netherlands,
Yeah, yeah.
Okay. Well, we actually visited Waag right before Corona kind of took over the world.
Yeah.
We were actually visiting Waag. It's a brilliant fab lab. It's really
It
great.
is.
Yeah.
It's very good. Yeah.
Yeah. We are actually trying to build a wet lab or a bio lab here as well, inspired from what we saw in at Waag. It's really impressive what they have built there.
Yeah, my graduation project was Inga's kitchen sink lab. So I built all the machines myself, and now I'm researching. In principle, I can do CRISPR-Cas9 experiments at home, but I think I shouldn't. So that's my research question at the moment.
Yeah. Okay. So are you working as a resource into the Fab Lab as well?
I got permission to use Waag Biolab, but due to COVID, I didn't go there for over a year now.
Of course, yeah. Okay.
Are you from Spinderihallerne?
Yeah.
Is that the Fab Lab where they burned the CNC machine?
Yeah. Yeah. That's us.
You're
we had
famous for that.
actually wasn't the one running it, but it was the year I took Fab Academy as well. And actually, I think it was we got some kind of famous for running big CNC. Yeah.
Yeah. Neil showed it to everybody, right?
You did, yeah. We still have it. We still have that shop bot, and it's actually we moved still in the old factory, but we got a little bigger area, and there was a lot of problem with the way we have made the exhaust and the way that the security around the shop bot was built. So we moved it, and it had taken a bit of damage by the burn. By the fire, but a second man here in the lab, Jacob, he has just finished rebuilding the shop bot, so it's up running again, the burned one.
It makes for a fantastic story, that's for sure.
Yeah, don't throw out the old machinery. Oh, it's an expensive machine for us, and it's a great machine. So of course we wanted to build it. It was insured, but the insurance were like, yeah, there's nothing wrong with it, but there was. But they didn't want to pay. Yeah, sometimes it's like that. Yeah, but we're still in the old spinning mill, the old factory, and it's bringing a lot of charm to the Fab Lab, like similar to Waag, having this historical old building to be in. It's an everyday pleasure.
But so you don't have a biolab yet?
No, we are doing experiments with biomaterials, and here we have this spirulina algae or bacteria. So we are doing a lot of projects with bio, but we don't have a separate lab with the bio. Oh yes, it's ultraviolet light and a pump, and then we're actually growing for the schools right now, so they can do experiments with spirulina algae or bacteria.
Okay.
but so we're doing a lot of projects, but we don't have the machinery or the surrounding for it right now. We're hoping for next year to build. We have an old storage room, which we are building into our biolab part.
And we've been seeking some fundings and hope we get some fundings to be able to do something more with biolab.
We have a lot of science teachers coming here as well from high schools, especially wanting to do STEAM and STEM with kids. And they are really into, can we grow something? Can we build something with the Fab Lab to grow something in the biolab, or can we make a biodegradable composite or something like that? So there's an interest for doing that in Vejle, but yeah, we just need the time and the right moment to do it. Oh, so it's and the distance.
We're working on it.
Okay, yeah, it's in progress.
We're getting there, perhaps.
Yeah. Does anybody else has a crazy idea or something funny to show?
Saw that Severio from Shanghai was laser cutting before. So
Oh yeah,
perhaps
he's laser
getting
cutting
somewhere,
there.
yeah.
I can see. Hey, that's a nice machine you have there.
It's very cool.
Yeah.
Oh yeah, it's getting air as well.
Yeah.
So it will cool you down
Cool
while
down
you
and feed your
select
M&Ms.
your
Yeah.
snack.
Yeah.
Yeah. I really want to see if you can control it with your foot, Johan.
Yeah, I'm working on it.
Or your knee or your elbow or something. Oh, yeah. Is it plywood? Or cardboard? Yeah, plywood. Oh, brilliant.
I'm just printing the.
Nice. Was it red?
It was green.
Oh, it was green. Okay. Oh, it was green.
You got a loop or what?
No, it says that the distance is like around 500 all the time. And I said if it's under 450, it should start.
This speed, you're gonna eat a lot of M&Ms. Like just red looking.
But that's not a problem.
No. Not before you run out of M&Ms.
It's a gift.
Yeah.
Yeah. Mm-hmm. You can hear when it's turned on, Johan.
Yeah. Let's say that's the idea. Langt du have to wrap up.
Er vi,
Der er ikke så mange, der bygger jo. Så kan tage tid eller noget.
Ja.
Eller du har 20.
Ja.
Hvad vil du have?
Nej, kvarter tid.
Ja, du har kvarter. So we're gonna build for around 15 minutes more, and then we'll see what you guys have been building or drawing, and we'll show you how far we've gotten with our projects. And then we'll wrap it up after that. So 15 more minutes of building, drawing, eating M&Ms. Can I have a straw, please?
Yeah, of course, Simon. It will,
The other way around.
oh,
It's a straw feeder.
it's a straw feeder, and it will maybe granulate your. No. I actually think it's a paper feeder.
Yeah, it might be. Oh yeah. Oh, it marks it.
Yeah, it was the. It's a cake cutter.
Yeah. That's actually nice.
Yeah.
You're doing like a paper box.
No,
or
the
paper
idea
lamp or
was
something?
actually if this could be on a string, and
Oh, yeah.
it could bring you the perfectly moist cake,
Oh yeah.
like a Lego air balloon thingy,
Thingy runs on a wire.
bringing your cake.
Yeah.
Yeah. Yeah, it's good.
It will be.
It will be. Yeah. What does it? It's still just a medium hard, but the cork cleaner is actually doing it well as a.
It's working.
Yes.
That's perfect.
So should we glue this on and test Peter's foot?
Yeah, I think we should.
My foot?
Yeah.
Yeah.
It's a foot feeder.
Anything for Fab Labs.
Oh, yeah. We'll have man.
No, then
Så jeg håber på at ligne alt meget på.
take it. Before we run for next week.
So nice information. Hot glue is hot.
Actually,
It is actually hot. Okay, so Peter, are you ready for testing
Yeah.
the machine with your foot?
So right now I will test Johan's shitty robot with my foot. So there's a distance. So if I was laying down on my couch at home and please stop. So oh, they're dangling. So I'm lying at home and I want an M&M and I can't decide which color. Yeah. And I will do like, yeah, turn it on. I need a green one, a green M&M, but then I need to, of course, have the M&Ms here at the couch. Yeah, of course.
Be very
It's
still.
dangling, yeah.
Oh.
It needs me to eat a lot of M&Ms.
I think it's actually qualifying as a shitty machine.
It's a real shitty machine, yeah. Cool. I'll just eat the green one then.
Yeah.
No, a orange one. Oh yeah, that's a double.
Well, the good part is now that you are eating candy and getting exercises to eating candy, so it's not. Oh, you're not getting too.
It's
too
really
heavy.
great. Yeah,
You have to move to get candy.
exactly.
Right?
Exactly.
If you don't move, then there's no candy.
No. Did you get your laser cutting done?
It's looking
Severio?
very. No,
No,
not yet.
no, not yet.
He has a few minutes left. He's working on. Last little bit. Could you please repeat, Severio, that it's, I think the sound was a bit late.
Firmware, so I'm
I said, okay, let's update the firmware. So now I'm at the computer designing the turbine.
Oh,
Okay.
cool.
Nice. Is it a Fablab you're in? Fablab in Shanghai or?
Wow.
Yeah.
Wow.
Nice.
This is just a new machine that I'm just starting to use now. Super big. It's a very 1 meter by 60, so I can do larger things. I'm very happy.
Yeah,
That's a good thing.
we have one at the same size. It's really nice to work with the big plates. You can really build something.
Yeah,
Are you
that's
running
it.
on Lightburn or
Say again?
are you using Lightburn or RDWorks or what kind of software do you use to run the machine?
Rayjet. This is like the entry-level Trotec. The R400 is like a cheaper one. I mean, cheaper.
Yeah, we know what you mean. Yeah.
Compared to the machine that you can buy in China, it's expensive, but compared to the normal Trotec, it's very cheap.
Okay.
And it was a donation by Trotec China that they donated it to the Fablab.
Wow.
So thank you, Trotec,
Yeah.
for donating the machine to us. I'm using it in the Fab event. They should be happy.
Oh, cool. So, Area, I think we will grab a cab and come and visit you in Shanghai.
Yeah, as soon as this thing ends, everybody has to come.
Yeah.
Free laser cutting for everyone.
Oh, yeah.
Is it an old Fablab? Has it been there for many years?
It's been open in 2013. The first manager was Anders Aldin.
Yeah.
He stayed here for 1 year, and then after him, I arrived in 2016. Sorry, it opened in 2014. Then I arrived in 16, and now I've been here for almost 5 years. This is my 5th year here in Shanghai.
Nice, and you're loving it.
I'm loving it. It's the Fablab is not very open to the public because it's in a university, but we got a lot of work with the students. It's a design school.
Brilliant. Yeah, that's brilliant. Good you're there, Severio.
Say again?
Good they have you. Good they have you there.
I'm
So
also
the last
happy
time-
that they got me.
So now it's the last 5 minutes of building and finishing up something to show.
Yeah,
Drawing.
let me go to
Yeah.
Yeah.
Virkelig godt, der er nogen, der er på. Sådan. Ikke?
Jo. Er gul, vel?
Der var en sandsynlighed ud her for, hvad vi har ramt. Der er gået en del grønne. Jeg kan muligvis komme til at spise nogle undervejs.
Det kan ikke være rigtigt. Jeg har en løs forbindelse et eller andet sted.
Det ved vi godt.
Ja.
Endelig. Det er jo andre ting, de overvist.
Den er løsning, der går helt andet. Nu ser det noget, der er 5 meter i kitchen.
Men det kan jo ikke være mit Lego, for det er jo dansk designet, ikke?
Mm-hmm.
Ja. Man kan godt lave et kagebord, som ligesom skubbede kage op fra midten.
Mm-hmm.
Så man selv var fri for at brække, altså en muffin brækker man jo tit i stykker, ikke?
Muffin chopper.
Ja. Ja. Og sådan en snegle drill, der sådan ligesom træk det op. Ja.
Når jeg er oppe af papiret,
Ja.
eller sådan. Ja.
Ja.
En skub op is. En automatiseret skub op is.
Ja.
Den der har jeg slet ikke været med på, hvad den billede er. Den var sjov.
Hvorfor den ikke med?
Den der.
Nå, den er.
Det var bare som afslutning.
Som afslutning, når vi vise et par stykker mere, der er nogen, der har lavet.
Jeg tror ikke.
still think. Jeg tror ikke, at den er på den.
Nej, men
Altså bare, når
Ja.
den har 3D.
Vi får nem at komme til.
om jeg tænker bare, der står der ting, der kunne nå den til.
Nå,
Men vi skal til at wrap up.
Ja.
Der er de
der
3
var en
minutter.
meget lang ledning i den. Altså sådan en meget lang.
Så jeg måske gå.
Stort træ.
Eller flasken.
Den passer altså som fod i hose på den her kapsel her.
Når vi afslutter, skal jeg så zoome lidt tættere på jer. Vi kan så vise, hvad jeg har lavet.
Måske ikke, det finder du ud af.
Men at servoen ikke var overhovedet kraftig nok til det der. Har I set de der skyder papirskriver afsted?
Har I set den?
Ja. Kræver en mere fart det her. Men er det ikke noget med, at den egentlig også bare kunne trække papirflyveren hen, og så ligesom der var en ladet? Er det ikke en elastik, der skyder den afsted?
Hun lavede den.
Lade den, og så... Ja.
Fængsel og lås. Så vi skal have en sluk den her gang. Det er helt med.
Men det er jo tit også måske et af problemerne, det der med, at så har eleverne bygget noget, og så sidder deres microbit ligesom fast på produktionen. Så det er godt at tænke ind som et benspænd også, at de kan
tænde og slukke og skifte
fjerne microbitten og bruge den i en anden, og så sætte den tilbage igen. Ikke?
Ja.
Så skal de bare huske at gemme deres projekt.
I hvert fald lidt fedt, at de så senere hen måske lærer at bruge en Arduino, så der
Ja,
man kan ofre.
enig.
Den virker lidt fint, men lige pludselig så får den et flip så kønt.
Det er perfekt for Shield Robots.
Ja.
Skal vi tage sammen?
Ja. Det er noget helt vildt.
Hvad siger du?
Det er noget helt vildt.
Der er næsten for meget.
Det er bare dobbeltfoldet papir, der så kan den næsten ikke. Du kører igennem den ene vinge, bare den ikke
Ja,
sådan.
der skulle lige lidt mere afstand imellem på en eller anden måde.
Så kan du 3D
Det er bare sådan, så hurtigt, så bliver det jo lige let for mig. Ja, det skulle jeg faktisk 3D-printe et hjul, hvor der ikke var så meget.
Den er tyndere her på vingen, så måske kan den køre igennem sådan her.
Ja, men de har meget tænder. Måske skal jeg bruge de glatte med noget elastik på.
Det der filament, Jacob har printet julen i.
Ja.
Det kunne være godt til lige at få fat i den.
Ja. Ninja Flex.
Så kan man bare eksperimentere med 4 meter, der bliver med.
Should we wrap up?
I think we should start wrapping up. Stand by for passiv tv, ser dem også på fjernsyn. Good. So I think we will kind of wrapping up, taking a little tour around, maybe see what you have been thinking, doing, maybe talk a bit about what we have been working on as well. So, Inger, did you make some extra thoughts into your project about the feather, the what is it called? Enthusiasm machine?
I didn't make any progress. because
Okay.
I'm in the middle of moving my stuff and everything is in boxes.
Of
So
course. I was kind of thinking if it has something to do with the kind of feather you are choosing. Is it a peacock feather, or is it like is it from a big bird or a small bird, or yeah? Does that mean anything?
I don't know what kind of a feather it is. I have
No.
it here because it was on my rooftop.
Yeah.
And I don't even know what kind of a bird it is because I
Oh,
never
so you
saw
have a
green
feather
birds.
in the house.
Yep.
Yes,
Yes.
can you see it?
Actually,
Oh yeah. Let's see it. Oh wow, that's a good feather, I think.
I wonder how a green feather comes up in the middle of Leiden because there are no green birds here.
no, it looks like a parrot feather, and I don't think there are any
Yeah.
green parrots in the Netherlands.
Are you sure?
No, I'm not. I've been many times, but never see a parrot.
I can tell you that Johan is having like a really red feather here. I think that the bird from that feather must be really exotic. Yeah.
Inga, when I was a teacher, I actually built something a bit like what you are drawing as an idea today. It was a chair, and it was connected to a makey that was connected to a Scratch program. So whenever some of the students felt like they had kind of an off day or felt miserable, they kind of sat in the chair, and when both arms were on the chair, it made a connection. So the Scratch program was programmed to say, well, you're okay, and tomorrow will be better, and please do your best, and stuff like that. And they actually used it. So it was really nice and a fun project.
Yeah.
I need that one.
Yeah.
Build something big. What about you, Saverio? How is it going at Shanghai?
The fan shape for the wait, let me on the computer. No, it doesn't show it. And then I already have an axis and some ball bearing.
Wow.
We connected to a motor. Oh no, it didn't come out very well.
Oh,
It's really shitty.
it's good. It's good to make mistakes. Just try one more time. It will be perfect.
Oh yeah,
Oh, it's beautiful.
One part.
That's a really good model, actually, I think.
But shitty is shitty for sure.
yeah. It's perfect for the workshop.
It's perfect. It's a shitty robot. I think that it will be. I really want to see if you make it work with the shower curtains, because I think there's something really exciting about. I know the feeling of that wet curtain. It's
Yeah. Even if you are already wet because you are in the shower, that's a different kind of wet.
But if it's blowing the air, doesn't it need to go inside the shower with you?
Yeah.
This one is done.
Yeah. It needs to suck the air.
Oh, that's a good bearing.
No, I was thinking of sucking out, so keeping it outside of the shower.
Yeah. Not that under pressure thing. So.
Okay, I'll keep doing them. Maybe is
Please
there a way
share.
to share stuff after? Maybe in the
Please share
event
your experience.
page?
Yeah.
Okay. Thank you,
And
guys.
I think that thank you. I think that the Nordic labs has gone. Yeah. So they had a different some different things on the program as well today. And what about Inga Gu?
Are you still on? And do you have a drawing or something?
That's the same person. It's Ingvar. I'm watching on a iPad and on the machine.
Yeah. Nice. Oh, good to know. Good to know.
Then I can walk around with my iPad and
so smart.
when I start programming, I have to be at my machine.
That's really good. Good thinking. So we were just, here is actually a soda opener from one of the kids from one of the schools. And I can tell you the shitty thing here was that the motor wasn't strong enough to open the bottle. So this actually comes with a really strong engine. And I just know that sometimes when we work with the teenagers and the kids, they're getting really annoyed by these small servo motors with 3 voltage or 5 voltage. So they want to upscale because these can't drag a lot. They can't give a slap that you can feel. It's like very tiny. So sometimes you have to scale up to make them do stuff. I want to close this session with telling you that we do this because at the schools, at the high schools, at the teachers, when we educate them, when we have the pioneers coming here, when we have the community coming here, we see a whole lot of different skill sets. We see a whole lot of different levels of skills people are coming into the Fab Lab with. And we just want really tell that technology should be for everybody. It should be for small kids, for big ones, for high level talent, for everybody out there. And here in Vejle, locally, we had a problem with the teenagers getting kind of lazy and kind of maybe dropped out of school, don't think it was that great anymore, and couldn't figure out what to do after public school. And we needed more teens, and especially more girls, also to getting interested in technology and work with technology. So we were talking about, we need to motivate them. We need to get everybody to work with technology and get the feeling that this is really great. It's creative, it's explorative, it's giving me an insight to do more things for myself as well and for others. And the Fab Lab is a perfect platform to show people that tech is for everybody. Technology and coding and program. It's not just for the talents. It's not just for the engineers. It's also for the creative mass, for the kids, for the small kids, for parents, for everybody. So Shitty Robot is just about having fun, doing technology, making the motivation go really high. And when you're done a machine like this with a whole lot of fun, then you're motivated, then you can do your next iteration, your next iteration, and your next iteration. And suddenly you are programming high-end controllers, you're programming and coding on a bigger level with small steps. So just do it. Build something. That must be the word from here before we close the session down.
Well, thanks you all for joining. Do you have any questions or any comments?
I'm so happy that you are here today. And please keep in touch. I think, Severio, we are friends on Facebook. Actually, I think you have this scanned figurine of yourself. I think I remember that, but please. Oh, wow.
Please present.
Oh, please. Wow, that is great. In such a short time. Wow.
I should hot glue this thing together. And this is the it's a distant sensor activated fan that will suck out the curtain.
Can I take a picture? Can I take a picture of it? Can you show it again?
Yes, this is my leg. So that the
Oh, that's brilliant.
Yeah.
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 And I'm making a screenshot.
Perfect shot.
Cool.
And you don't want to let it suck too much, then it will suck in the curtain and it will spin it around.
Oh, this is brilliant. This is brilliant. I'm really looking forward to seeing how this goes on. Racing enthusiast. Brilliant, Shitty Robots. That's really good. But
So thank you for joining and good job, everybody.
good job. Yeah,
Hope to see you around.
I hope to see you. Maybe next year's conference would be more physical at Bhutan. So we were looking forward to maybe see you there in real life. Thank you. Bye bye. Yeah, Severia. Oh, bye bye. I'm mute, så luk kameraet.